Spotted Kestrels. This is another revision video for you for your week 3 summer learning for your maths with ordering and comparing fractions. Just going back to earlier what we were talking about in terms of wholes and how they always need to be the same. So remembering that we have a whole that's exactly the same. So if I put them on top of each other, you can see that they are exactly the same. But where they have been divided into their equal parts, they have different equal parts, but their whole is still the same. So we know that 4 quarters equals a whole. We also know that 8 eighths equal a whole as well, and so forth with 3 thirds, 8 eighths, 9 ninths, 1 quarter, 2 quarter, 3 quarter, 1, and then we know the same as we count up through our number sequences there. So today we're having a think about improper fractions and mixed numbers and how we can use that knowledge that we've got with regards to ordering and comparing fractions above 1. So to begin with, I want us to have a think about 5 thirds and let's say 4 sixths. And I want us to have a think about using a representation first, about how to work this out. Now I'm going to need 2 representations for this top one, and you're going to see why in a moment. Now remembering, all our representations need to be exact, okay, because our whole is exactly the same, always the same. And we need to do that by using squared paper or at home with a ruler. There we go. Okay, so my 2 up here are going to be representing my 5 thirds. Why do you think I did 2 of these? That's right, because the top heavy improper fraction here knows that I've already got a whole in here somewhere, and then I've got a remainder for an improper fraction. So my whole would be made up of 3 thirds. Remember earlier we spoke about 3 thirds being the same or equivalent as 1. And I had 5 parts to shade. So I've shaded 1, 2, 3. I've got another 2 to shade. Okay, so that's my representation of 5 thirds. 1, 2, 3, 4, 5. Now I know that 3 of those thirds equal 1. So I know that actually I could write that as well. That's my representation. So now I need to go on to 4 sixths. Okay, and I've got this here. 1, 2, 3, 4. Now you can see straight away that 4 sixths is a lot smaller than 5 thirds. Now we know that straight off from looking at that because our numerator isn't heavy. Okay, it's not heavy. There is less amount shaded in than there is to make the whole. But let's say, for example, I change that and I now want to know whether 5 thirds are bigger than 8 sixths. So I need to colour in 8 sixths. I've got 1, 2, 3, 4, 5, 6. Now again, just like I did up here, I can convert that and I know that 6 sixths equal 1. Need to colour in 8 sixths. I've got 2 left over. 1, 2. Now we can see that as a whole, we've got 2 of those. We converted this to 1 and 2 thirds. We've got a 1 here, and we need to convert this into something else. So now this is 1 and 2 sixths. So you can see from this straight away that yes, they both have a whole. They are both equal, those wholes. But it's this part that we're looking at. And this is just like you will have done with your comparing and ordering fractions below 1. That now you have 2 thirds and 2 sixths. And you can see that the 2 thirds is bigger than the 2 sixths. So let's do one more of those. And this time we're going to use quarters and eighths. So I'm going to see if 6 quarters, I'm going to check, find out whether it's bigger than, let's do 12 eighths. Okay, let's go. This is going to be the first one that we need for our quarters. So I need to colour in 6 of them. Now I know that a whole is already 4 quarters. So that would make 4 over 4, but I've got 2 left because it's 6 quarters. 1, 2. So actually I know that 6 quarters is equal to 1 and 2 quarters there. Okay, so that's what I've got there. I now need to check 12/8. Okay, so again, my whole needs to be exactly the same as my quarters. So I can make that the same here, but I need to make it into 8s. So I'm just going to halve those. Okay. 12/8. 1, 2, 3, 4, 5, 6, 7, 8. Again, I know that 8/8 equals 1, but I've got 4 more to do. 1, 2, 3, 4. Now, 1, I've shaded in 4/8. So 1 and 4/8. 1 and 2/4. Can you see what I have got left over here? 1, 2, 3, 4. 1, 2. Now, although it looks like I have more in terms of I've counted up more, they are exactly the same. And this is why your holes need to look the same. Because you can see here that I've got 2 quarters, but I've got 4/8 left over. So actually, 6 quarters is the same as 12. And carrying on now, if we were to have mixed numbers, we would see that straight away as the same in terms of our representation. So I'm going to say I've got 1 and 2/3, and I want to see whether it is bigger or smaller than 1 and 3/6. Now you might be able to think instantly, you know what that is, and that's brilliant. And you may think, oh, I think I'm okay with that, but I just want to make doubly sure. So let's give it a go. We know that from here, our whole is made up of thirds as well as our fraction here. So we need to put them into thirds. Now I've got a whole here, so I know that that is made up of 3/3, and I've got 2 over here, 1, 2. Okay. Now altogether, I know that that comes as 5/3. 1, 2, 3 that make up the whole, and the 1, 2 that's as part of our mixed number. Okay, so then we do the same for the 1 and 3/6. Again, our wholes are exactly the same, although they don't look quite the same down here, but they are meant to be. And these are 6, aren't they, this time? So I have a whole here, up there. 1, 2, 3, 4, 5, 6. And I've got 3 6s here. 1, 2, 3. Okay. And if I add these together, I don't have 9/12. Remember, my denominator always stays the same. I have 9/6. Okay. Now you can see that I've got 3 parts left over here, or a half, and I've got 1/3 left over here. So you can see from this that 5/3 is bigger than 9/6. Okay. So I put that like that. Now, another way to check that as well is that we've got 5/3 and 9/6. 5/3 and 9/6. Okay. Now, thinking about what we already know and what we did last week with regard to equivalent fractions, to find the equivalent fraction for this, for 6, what do I need to do here? Notice the relationship between the 3 and 6, times it by 2. If I did exactly the same here, I can see that 10/6 are bigger than 9/6. So that's one way to have a check through your work. Give it a go. Any problems, give us a shout and we'll be happy to help.